This is 3.5. You kind of know how to do all of the questions already. Some of them are actually really, really easy, but let's get started. What are the roots of this? Well, we know how to factor polynomials, and we know how to find the roots when you have a linear factor. So the number of of factors will be determined by the highest exponent in each set of parentheses. So this one has 2 roots, and this one has 1 root. And that's a really easy one. We just set it equal to 0. Add 14. So 7y equals 14, and divide by 7. So y is 2. That's one of the 3 roots. Okay? And then for the other one, we need to factor. Are there 2 numbers that multiply to be negative 24 and add to be 2? That would be plus 6 and minus 4. What is the root for that one? Negative 6, and the root for this one would be 4. So it's just factoring, but in this case we have a quadratic multiplied by a linear, which means we have 3 roots. All right. Do you guys remember the quadratic formula? So the quadratic formula, it's always right here if you need it. Negative b plus or minus the square root of b squared minus 4ac over 2a. And the quadratic has to be in order. Well, I guess not really, but the a term belongs to the x squared, the b is part of the x, and c is the constant. So this would be negative 3 plus or minus the square root of 3 squared is 9. And then I need to do negative 4 times negative 7, which is 28, times 2, which is 56. Over 2 times a, which is 4. 9 plus 56 is going to be 65. So negative 3 plus or minus the square root of 65 over 4. What goes into 65? 5 and 13. Can I take anything out? No. So that's actually as far as it goes. Uh-oh. I think somebody's calling me. How dare they? What if I had 6 plus or minus the square root of 24 over 8? If we factor 24 down, I get 2 times 2 times 2 times 3. What can I take out of that? A set of 2's. And I bring that to the front, so that would be 6 plus or minus 2 root 6 over 8. Can I simplify anything there? I can take a 2 out of everything except not in here. The stuff in there is not really a 6. It's the square root of 6, which is kind of like the exponential half of a 6. So it doesn't work that way. But I can take a 2 out of all of those, and we get 3 plus or minus root 6 over 4. What if there was a negative on the inside? And I'm going to have an I. Where do I put the I? Outside the parentheses, like that. Okay, you guys remember quadratic formula? All right. And it says exact answers. And it says separate with commas. So you'd have to do, whatever your answer is, you'd have to do like 4 minus root 3 over 7, and then 4 plus root 3 over 7. And when it says exact answers, it means don't give the decimals. So you're just going to write out the fraction like that. Because if we plug it in our calculator, we're going to get a decimal that goes on forever. There's no way to write all the decimals down. So every decimal that you write down is an approximation. All right. So I have 5 roots, and I need to create a polynomial that has all of those roots. Well, if I know that the graph hits the x-axis at -3, then I can guarantee that one of the factors is x plus 3. And another one would be x minus 7. And another one would be x minus 1, and x minus 9, and x plus 0, or x minus 0, which is really just x. And then you have to multiply all those together. Kimber panicked a little bit. No, you don't. Yes. Yeah, that will be the answer. So you could multiply them all together, and you'll get a big, long x to the 5th polynomial. But if you plug that into a graphing calculator, it will hit the x-axis at 0, 9, 1, 7, and -3. What was your question? Okay. So those are really, really easy. All right, we have a rectangle. And we know that L is 3 less than twice the width. So I just write it out according to that sentence. L is means equals 3 less than twice the width. So if this is W and this is L, we can replace L with 2W minus 3. So the area would be W times 2W minus 3, which is 2W squared minus 3W, and that is equal to 44. So I just subtract that 44 to the other side. 2W squared minus 3W minus 44. You can factor it, or you can use the quadratic formula. Let's try factoring it. So 2W squared and -44. I actually know that it's going to factor. How do I know that? Any idea how I know it's going to factor? Look at the title of this topic. Solving a word problem using a quadratic equation with rational roots. What are rational numbers? Fractions. So if I know the answer is a fraction, then I know it's factorable. All right. 2 times -44 is -88W squared. Are there factors of -88 that add to be -3, 8, and -11? So 8W, -11W, pull out a 2 and a W, and I get W plus 8. And then I take out a W, and I get 2W minus 11. So W plus 8 equals 0, and 2W minus 11 equals 0. So my roots are -8 and 11 halves. What do you guys think about those? Wait, did I go too fast? Oh, I did it wrong? What did I do wrong? Oh, it should be a 4, huh? Does that make you feel better? Okay, thank you. What do you think about those answers now that they're correct? Anybody have issue with one of those? No. Let me try again. -4 and 11 over 2. Ah, I did it again. So -4 and 5.5. What do you think about those two answers? One of them doesn't make any sense. Why not? It's negative. So the goal here is to find the dimensions of the rectangle. So if W equals -4, then I should plug it in to here and to here, and I get a rectangle whose length is -4 and then -11. That doesn't make any sense. So we throw away the negative, and we get 11 halves. So this is 5.5, and then we stick 5.5 in there, and we get 11 minus 3, which is 8. So the lengths are, the width is 5.5, and the length is 8. All right. So for this problem, I want to know what could the fractional answers be. And the way we do that, remember, is we list all of the factors of 5. So that would be plus or minus 1, plus or minus 5. And then we take all of the factors of 5 and we divide them by all of the factors of 7. So 7 only has 1 and 7. So I need to divide each of those by 1, which is something we already have, and then divide them all by 7. So plus or minus 1/7, plus or minus 5/7. Okay. How can we make sure that no value appears more than once? If a fraction simplifies, don't put it in. Okay. Anytime you have a fraction that has a common number in the top and the bottom, don't stick it in because it's already in there somewhere. So let's try another one of those. That one was a little too easy. Okay, here we go. So we look at the constant, plus or minus 1, plus or minus 5. That's not a good one. Let's say this was a 4. Plus or minus 1, plus or minus 2, plus or minus 4. Oh, let's say this is a 6. Okay. What's that? -2. Oh, good call. All right, so good catch. It's out of order. So let's say this was a 6 and this was a 4. I didn't even notice that. Well done. Must be Friday. I'm all over the place today. Okay, so the factors of this would be plus or minus 1, plus or minus 2, plus or minus 4. And then the factors of 6 are 1, 2, and 3, and 6. So I need to divide all of the numbers in my list. I don't need to divide by 1. I already have those. By 2, and 3, and 6. But if that simplifies, then we don't have to put it in. So plus or minus 1/2. 2 over 2, we don't need to put. 3 or 2 over 3, we do. But 2 over 6 simplifies, so I don't need to put that in. Oh, my heavens. I'm going to go back to sleep. Plus or minus 1/2. So 2 halves and 4 halves, they both simplify. Okay, then I move on to divide by 3. Plus or minus 1/3, plus or minus 2/3, plus or minus 4/3. Then I divide by 6, plus or minus 1/6. 2 over 6 simplifies, and 4 over 6 simplifies, so I don't need to stick those in there. Man, I did not bring my A game. Maybe it's how I dressed this morning. Maybe it's getting to my brain. All right. All right, find the x and y intercepts. The y-intercept is the easiest. Where does this graph hit the y-axis? -16. The constant is the y-intercept. What if there is no constant? Then it's 0. Okay? So, where could this hit the x-axis? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. So up to 3 of those can be correct. And we're going to test using synthetic division. What is the easiest one to test? 1. How do you test 1? You add up all the coefficients. Is 1 plus 1 minus 16 equal to 0? No, so 1 didn't work. So we throw that out. Okay, so what do you want to try? Negative 1? Well, that's a good idea. Why did you pick negative 1? Oh, well, okay. Can you look at it and see negative 1 is probably going to work? We had 2 positive 1s and 2 negative 16s. If we could change 2 of the signs, then it's going to work, right? If we could change the first sign and the third sign, or the second and the fourth, then it is going to work. So negative 1. Am I missing any numbers? 3, 2, 1 constant, so no. 1, 1, negative 16, negative 16. Drop the 1. Negative 1 gives me a 0. And then 0. Negative 16. Positive 16, which gives me a 0. And actually, if you want to know, if you change every other sign and you get a 0, then negative 1 is going to work. So 1 is really easy to test. You just add up all the coefficients. But if you change the first sign, skip the second, and change the third, skip the fourth, and change the fifth, if you do that and add them up and you get 0, then negative 1 is going to work. So that's kind of another trick. So my y-intercept is negative 16. My x-intercepts are negative 1. And then I get a quadratic equation here, x squared minus 16. How does that factor? X plus 4 and x minus 4. So 4 and negative 4 are the other 2 roots. Okay. All right. Plus or minus, plus or minus 1, 2, 4. And then 10 has a 2 and a 5 and a 10 in it. So 1 half, 2 halves, and 4 halves. Simplify. 1/5, 2/5, and 4/5. And then 1/10. Hopefully we won't have to guess any fractions. Okay, is 1 going to work? 10 minus 4 minus 1 plus 4, is that 0? No. Is negative 1 going to work? Change the first one, change the third one. Does that add up to 0? Nope. So none of these work. Okay. So let's try. Let's try 2. Am I missing any numbers? Nope. So 10, negative 4, negative 1, and 4. 2 times 10 is 20. Excuse me, 16, 32. That's not going to work, right? Not even close. Okay. Are they all going to be fractions? Is that? No, they can't be. One of them has to be. Which one's going to work? Oh, I'm doing the problem wrong. It says find all possible rational zeros. Okay, it didn't say solve. There we go. But it turns out that none of them work. How do I know none of them work? Because I've been doing this for a really long time. But yeah, we didn't need to solve that one. We just needed to write the possibles. That one actually didn't factor. Okay. So this is just like the one we did before. Plus or minus 1, plus or minus 3, and then plus or minus 1/2, 3/2, 1/5, 3/5, and then 1/10 and 3/10. Now we need to find the roots. Does 1 work in this case? No. Does -1 work in this case? No. So let's try 3. So we try 3. Are we missing any coefficients? Nope. 10, -33, 8, and 3. 30. No, 10. Nope, 10. I'm going to go home. 3 times 10 is 30. -33 plus 30 is -3, which gives me a -9, which gives me a -1, -3, and 0. So I now know one of the roots is 3. How do I find the other two? I create a quadratic with this. X squared minus 3x minus 10x squared minus 3x minus 1. And then you either quadratic formula or factor it. We factored the last one. Let's use a quadratic formula. So 3 plus or minus the square root of 9. -4 times -1 is 4 times 10 is 40 over 20. 9 plus 40 is 49, and the square root of 49 is 7. So we get 3 plus or minus 7 over 20. 3 plus 7 is 10. 10 divided by 20 is 1/2. 3 minus 7 is -4, and -4 divided by 20 is 1/5. Okay. Now, an interesting thing about this is these factors are 1, 2, 5, and 10. And these factors are 3. Notice we can create a 3 and a 10 using those numbers. And that will always be the case. The answers you get will always recreate the leading coefficient and the constant. Did I lose somebody? Okay, sorry. So 3 plus 7 is 10, and 10 over 20 is 1/2. 3 minus 7 is -4. So it should be negative. Thank you. Thank you. It's a good thing this isn't recording, so my future classes will never know how bad I am at math. It is. All right. Is it Friday yet? Okay. So, what could the answers be here? Plus or minus 1, plus or minus 7, plus or minus 1/3, plus or minus 7/3. Okay. Will 1 work? No. Will -1 work? No. So let's try 7. I'm not missing any coefficients. 3, -4, -20, and 7. 7 times 3 is 21. -4 plus 21 is 17. That's not going to work. We're going to have to try a fraction. Negative 7 is not going to work either. That would be negative 21, which is negative 25. And 7 is only going to make that number bigger. And there's no way I'm going to get a 0. All right, so let's try 1/3. Now, when you do fractions, there's something you have to remember at the end. Divide the equation by, in this case, 3, because it's the denominator of the root that I'm testing. So drop the 3. 1/3 of 3 is 1. So that gives me negative 3. 1/3 of negative 3 is negative 1. So that gives me negative 21. 1/3 of negative 21 is negative 7, which gives me a 0. Now take the resulting equation and divide it by 3, which yields x squared minus x minus 7. Does that factor? Are there factors of negative 7 that add to be negative 1? No. What does that mean? Does it mean that those two roots are imaginary, that it does not cross the x-axis? Not necessarily. What does it mean when a quadratic doesn't factor? We have to use the quadratic equation because the answers are not nice. They're either irrational or imaginary or both. So we have to plug that into the quadratic formula. So 1 plus or minus the square root of 1. Negative 4 times negative 7 is 28. Times 1 is 28 over 2. And I get 1 plus or minus the square root of 29 over 2. So this graph hits the x-axis at 1/3. And then it hits again at those two nasty numbers. So it would look, I don't know, something like this. Okay, I should be done doing math today. I think I made more mistakes today than I have the whole rest of the year. All right, get to work. 3.5.